This is one of those questions that sounds almost too obvious to ask until you actually start digging into the specifics. And then it turns into one of the most genuinely fascinating rabbit holes in the history of human evolution. And it involves a number that sounds made up, 93%. Imagine standing on the African savanna over 1 million years ago, where a group of early humans is crowded around a fire. The flames crackle, illuminating faces marked by curiosity and awe. Little do they know, this fire is about to spark unimaginable changes in both their bodies and societies. Changes that would shape the course of human history. Do we truly understand how fire altered human evolution? And if so, why has this impact been so profound and consistent across different periods of history? Let's start with a concept called thermal processing. Simply put, it's the way cooking changes the nutritional value of food. When early humans started using fire to cook, something remarkable happened. Cooking meat breaks down its proteins, making it easier to chew and digest. In fact, cooked meat can provide up to 30% more energy than raw meat, an astonishing leap. Picture a group of Homo erectus about 800,000 years ago, in the lower Paleolithic period, roasting meat on an open flame. Not only did this provide more calories, but it also reduced the time spent chewing by 50%. Suddenly, members of the group had more energy and more time, key factors in human survival and evolution. Now, here's where this gets even more interesting. In a different context, let's consider the cooking of plant foods. Boiling or roasting tubers and roots renders certain nutrients bioavailable and breaks down toxins. Archaeological findings from Gesher Benot Ya'aqov, a site in Israel dating back about 780,000 years, reveal charred remains of these very foods, showing that early humans were maximizing their nutrient intake well before agriculture. However, this idea of thermal processing sounds like it should apply universally, but interestingly, there's a twist. Some early human groups like the Inuit primarily consumed raw meat and organs due to their environment. This seems like it contradicts everything we've discussed, but their diet was rich in vitamin C and other nutrients from raw sources, which worked exceptionally well in that context. This exception tells us that while thermal processing was transformative, humans also adapted to their specific environments, giving us a richer understanding of how versatile and resilient we are. So, why does thermal processing intersect so deeply with our evolution? It opened doors to diverse diets and allowed us to thrive in various ecosystems. But how did fire itself influence the way humans lived and organized? Or what scientists often call the hearth hypothesis. The idea here is that fire wasn't just a tool. It became a social catalyst. The hearth acted as a gathering point, where stories were shared and bonds formed. This isn't just speculation. There's solid evidence from archaeological sites like Wonderwerk cave in South Africa, where habitual fire use dates back 1 million years. These sites are rich in evidence of communal living, showing how the hearth space likely played a pivotal role in social evolution. Consider another example from around 400,000 years ago at the Qesem cave in Israel. Researchers found circular hearths around which people organized their living spaces. The proximity to fire not only provided safety from predators, but also facilitated social interactions. It's compelling to think how such arrangements could have directly influenced societal structures and communication. Here's a contradiction to chew on. Some argue that the development of agriculture, not fire, was the primary driver in forming complex societies. While agriculture transformed human societies on a grand scale, the hearth hypothesis suggests that the seeds of social cohesion were planted long before, around communal fires. The reality is that each played a role at different stages, but the social warmth around fire was crucial for our ancestors, long before agriculture took hold. So, how did this environmental and social shift catalyze other aspects of evolution? The hearth wasn't just about warmth and safety. It changed how we communicate and cooperate. This makes us wonder, what role did fire play in cognitive evolution? Here's where we encounter the idea of cognitive mapping. Essentially, fire not only changed our diets and social interactions, but also expanded the human brain's capacity. Cooking allowed for increased calorie consumption. Remember that 93% stat? That's the amount of energy our brain consumes from our basal metabolic rate. With more energy available, early humans could afford larger brains, leading to heightened cognitive abilities. For instance, the increase in brain size and complexity around 1.8 million years ago does not coincide with evidence of controlled fire use. These evolving cognitive skills weren't just abstract. They allowed for advanced toolmaking and strategic planning. Imagine a group of Homo sapiens around 125,000 years ago, crafting stone tools with precision and forethought, using fires for both light and inspiration. However, a curious exception arises with Neanderthals. They had comparable brain sizes, but no substantial evidence of advanced cognitive mapping, as seen in modern humans. One hypothesis is that their intermittent and opportunistic use of fire didn't support the same dietary and social advantages. This disparity hints at the complexity of our development, and shows that fire was not a magic bullet, but part of a suite of evolutionary changes. This loop back to cognitive mapping reveals the complex web of how fire influenced human intelligence. But can we quantify this impact in the long run? This leads us to the concept of ancestral memory, or how fire impacts collective learning. Over generations, the use and mastery of fire became encoded in our cultures through stories, rituals, and knowledge passed down. This collective memory is evident in the rich cultural traditions of indigenous communities, where fire management is seen as both a practical tool and a spiritual one. A powerful historical example lies with the Aboriginal Australians, who have used fire management for tens of thousands of years. Their systematic fire stick farming enhances biodiversity by promoting new plant growth. This is a striking example of the deep cultural memory surrounding fire use, illustrating how knowledge is passed through stories and teachings. But not all past societies adopted fire management uniformly. Take the ancient Greeks, who often viewed fire as a destructive force, evident in myths like Prometheus. This divergence suggests a complex relationship with fire across cultures, emphasizing that while fire's benefits are universal, its perception and use vary widely. Thus, fire's role in human evolution is a fascinating case of how a single element can shape multiple facets of our biology and culture. So, what does this mean for our understanding of human resilience and adaptability across millennia? Let's explore the idea of geothermal ingenuity, which describes how human innovation flourished around natural thermal features. Harnessing geothermal heat was not just about survival. It sparked technological advances and settlement patterns. Ancient cultures located near geothermal areas, like the 6,000-year-old settlements of Çatalhöyük in Turkey, were not specifically known for using natural heat for cooking and heating homes, marking a significant leap in human ingenuity. In another case, consider the Romans and their utilization of geothermal springs. Bathhouses with thermal waters became central to Roman social life by 43 AD, with Bath in England being a prime example. The Great Bath could hold approximately 240,000 litres of naturally heated mineral water, demonstrating both engineering prowess and the societal benefits of geothermal resources. Yet, geothermal ingenuity wasn't without its difficulties. In regions without natural hot springs, societies had to innovate differently, such as developing insulation techniques or different forms of architecture. This challenge underscores human adaptability and the diverse ways we capitalized on thermal resources beyond open fire. This concept of geothermal ingenuity showcases how environmental factors and technological innovation have intersected throughout history to influence human societies. Could this touchstone of adaptation be the stepping stone that led to the modern era's energy solutions? The final takeaway? Our relationship with fire illustrates a quintessential part of human evolution. Our ability to adapt and innovate in the face of both opportunity and challenge. Just as those early humans gathered around primitive fires, modern society continues to rely on the foundational developments fire brought. And in this way, the warm glow of that first fire on the African savanna still echoes in the energy that fuels our world today.